Welcome! Have you ever built an absolutely flawless Go API only to watch your front-end team completely struggle because they just don't know how to use it? Well, today, we're unlocking a true developer superpower. In this explainer, we're going to explore the absolute magic of effortlessly auto-generating beautiful, interactive API docs right from your Go code comments. No more manual updates, no more disconnected wikis, just seamless, accurate, living documentation. We've all been there, right? Picture this. Your backend endpoints work perfectly, but your front-end developers or external consumers are, well, they're frustrated. Why? Because the instructions on how to use your API are scattered across outdated README files, forgotten wiki pages, and lost Slack messages from 6 months ago. Relying on this kind of fragmented info causes some real visceral pain when you're debugging. It wastes hours, triggers unnecessary support tickets, and frankly, it just makes your API look unprofessional. Documentation isn't just a nice-to-have. It's the fundamental contract between your backend and everyone who consumes it.
Okay, let's dive into this. Here's our roadmap for today. 1. The API documentation problem. 2. Meet Swagger and OpenAPI. 3. Setting up GoSwag. 4. Documenting endpoints and models. 5. Best practices and security. And 6. The OpenAPI ecosystem power.
Section 1. The API documentation problem. Why bad docs break your team. Good documentation saves time and builds immediate trust. Adopting a standard like Swagger solves massive developer pain points. Let's look at the top 2 benefits here. First, an interactive UI. This isn't just a static document. It provides an actual interface where developers can test API endpoints directly from their browser. Second, and this is absolutely crucial for us backend developers, it's auto-generated. There's zero need to write documentation manually in some separate file. You generate it straight from your code comments. It also standardizes the process, allows for easy version control of your API changes, and can even automatically generate client SDKs in multiple languages. It literally takes documentation from being a tedious chore to a seamlessly integrated part of your development lifecycle. Section 2. Meet Swagger and OpenAPI, clarifying the industry standards. In the tech world, these 2 terms are constantly used interchangeably, but there's a really distinct difference we need to establish. So the crucial point is this. OpenAPI is the actual standardized specification. It's the machine-readable format for describing Rust APIs, and it's maintained by the Linux Foundation. Swagger, on the other hand, was the original specification created by SmartBear, but today it refers to the ecosystem of tools used to actually implement that specification. So practically speaking, when someone says use Swagger, they almost always mean use the OpenAPI specification paired with Swagger tools. To give you a clear visual, here is what the OpenAPI specification actually looks like under the hood. It's just a simple, standardized YAML or JSON structure. You can see it defines the OpenAPI version, the title of your API, the current version, and the base server URL. This straightforward, machine-readable backbone is exactly what all those fancy Swagger tools parse to visualize your entire API ecosystem. Section 3. Setting up GoSwag. From zero to Swagger in minutes. If you're building a Go API, the most common tool to bridge your code and the specification is called Swag. The setup sequence is incredibly fast. First, you run a quick go install command to get the Swag tool. Second, you grab the Gin Swagger middleware, assuming you're using the super popular Gin framework, of course. Third, you add a few high-level comments to your main function, like your API's title, version, and base path. And fourth, you simply run swag init in your terminal. Swag immediately scans your code, parses those comments, and boom, it generates a docs folder containing your JSON and YAML files. It really is that fast to lay the foundation. Section 4. Documenting endpoints and models, writing the contract in code. All right, here is the absolute meat of how this works. You document individual endpoints using specific annotations directly above your Go handler functions. Notice how narrative and logical these are. Use summary and description to tell humans exactly what the endpoint does. Use tags to group related endpoints together, kind of like putting all user-related routes under a Users tab in the UI. Param is incredibly powerful. It defines your query or path parameters, like specifying that a page query is an integer, whether it's required, and even setting a default value. And for sure, success and failure define exactly what the consumer will get back, mapping directly to your Go structs. These simple comments visually translate into the interactive UI, letting developers instantly test endpoints with the right parameters. But your endpoints don't just exist in isolation, right? They consume and produce data models.
And this brilliantly illustrates how Swagger handles that. Look at this Go user struct. Beyond standard JSON tags, we're adding Swagger-specific tags, like example equals John Doe or enum equals active-inactive band. By injecting concrete, real-world examples and constraints directly into your data models, the documentation truly comes alive. When an API consumer views your docs, they don't just see a sterile note saying, name is a string, they see a populated payload with John Doe. They immediately understand exactly what the API expects and returns.
Section 5. Best Practices and Security. Polishing and protecting your API. Almost all real-world APIs require authentication, and if it isn't documented, your consumers are flying totally blind. Swagger makes this incredibly straightforward. First, you define your security scheme at the top level of your API. For instance, you could set up a bearer token for JWTs. Then, above any protected endpoint, you just drop in a security annotation. When users open the UI, a little padlock icon magically appears next to the endpoint, and they're prompted to enter their credentials. It ensures consumers know exactly how to authenticate, right from the jump. To truly master API docs, you need to treat them like a living, breathing contract. Here are the golden rules. Be descriptive. Write for humans, not machines. Include real, concrete examples liberally. Crucially, document your error responses. Don't just show the happy path. Tell developers exactly what happens when a user isn't found or an input is invalid. Use versioning in your pads. Keep your documentation dry by relying on tags as the single source of truth, and actually test your docs in the UI to make sure they match reality. And above all, update your comments as your API evolves. Remember, documentation debt is just as destructive as code debt. Section 6. The OpenAPI Ecosystem Power, Unlocking the True Potential.
Now, what's really interesting about this is that the single file you generated actually unlocks an entire universe of tooling. You get the beautiful UI for interactive exploration, of course, but look at the OpenAPI generator. From your single spec, it can auto-generate client SDK libraries in over 50 different programming languages. No way, right? You can also import your spec directly into Postman to instantly generate automated test collections, or use Stoplight for API design and governance at scale. The documentation becomes an incredibly powerful bridge connecting your Go backend implementation to the entire software development ecosystem.
Which brings us to our core takeaway from the source material. Good API documentation is a superpower. It really, truly is. It reduces support overhead, drastically speeds up onboarding for new team members, and makes your API genuinely enjoyable to work with. The investment you make in adding a few comments above your Go functions pays dividends immediately in building trust and confidence with your consumers. Once you experience the power of auto-generated interactive API documentation, you will literally never want to go back to manual wiki pages. So, as you spin up your next Go project, ask yourself, will you keep writing manual docs that instantly go out of date, or will you let your code write the contract for you? Thanks for joining me on this explainer, and happy coding!